Okay, so I have our syllabus pulled up here. We're going to finish lesson 5 today, which means I did the teacher-led demo portion last class, and we're going to start with the activities today. Then we're going to do lesson 6, right? And then I just want to point out that next class on Thursday, we're going to have Quest 1. Okay, we'll have part of the class will be some review. The second half of class will be the quest. And Quest 1 covers material from lessons 1 through 5. Okay, so today we're going to do lesson 6, but it's not going to be on the quest, right? So stuff that we do today that's brand new will not be on the quest next class. And then I did get a couple of emails from people regarding the homework on dimensional analysis and ratio and proportion that's due today on the 15th, right? It's a supplement, like that material is not directly from your textbook. So the homework problems were written by myself and or Ian Winokur, another professor. And so that's why there's no help me solve this button for those particular problems. And that's why when you get it wrong, it just tells you the answer and says try again, and it doesn't give you new numbers. You can still keep trying that problem as many times as you need to until you get it right. But you don't get new numbers every time. And that will happen, I don't know, maybe 2 times throughout the semester where we added a topic that we thought was important but isn't in your textbook. Yeah, we typically don't do that in class. I have an office hour right before class, 9 to 10, or right after class, so we can talk about it too. Yeah. Or during the activities time when we're walking around doing work, I can stop and answer a question or two. Okay, so if you remember last class, we did this demo portion of lesson number 5, and we talked about slope. And slope is always change in y over change in x, right? It's always vertical change divided by horizontal change. That's how we measure the steepness of a line, and we call it slope. So this is all stuff we did last class in the demo. And we calculated the slope for that hot air balloon problem, and we used the units to analyze what the slope meant, and it said that balloon is falling at a rate of 200 feet per minute. Right, so that negative sign got interpreted as the word falling. And we figured out that you can use any 2 points on a line to calculate its slope. It'll always give you the same number. And you can do the subtraction in any order you want, as long as the subtraction on the top and the bottom have the same order, right? So that's sort of like, very briefly what we went over in the demo portion at the end of last class. And then we're going to start today on the activities that deal with slope. So this is page 37 in your packet. This is where we're starting today. We'll do this for a little while, then we're going to do lesson 6. I wanted to tell you about preparing for the quest. So you've got quest 1 next class. Last class I gave you a packet called practice problems, extra practice problems. So if you log into our course Moodle site, which is where I am right now, there's a block at the bottom called quest/test prep material, and there's a PDF called 096 practice problems. I handed this out to you, so you all have a hard copy. If you didn't get one, I have some more, or it's always in Moodle. You can print it if you lose it. So it looks like this, practice problems for Math 096. And your quest that's coming up is on lessons 1 through 5. So the problems next to lessons 1 through 5 are problems that correspond with those lessons, right? So you might want to do this set of problems to help prepare for the quest. Now, if you're having any trouble solving those, figuring them out, then you come back to your quest test prep material block, and then there's another PDF underneath that says solutions. So if we open that one up, you get a PDF where all the work is shown for every problem. So you can try to follow the written work, right? Or there's a link that says solutions videos. So this takes you to a playlist in YouTube, and each of the problems in that packet has a video of somebody solving it and talking you through it as they do the work. All right, so you have a lot of resources in terms of extra problems that you can work through and their solutions to help you get ready for the quest next class. All right. Oh, I don't remember. Probably somewhere between 5 and 10. Probably multiple parts, you know, break it down just like I do in your activities. All right, now you can start your activities. Okay, we're starting lesson 6. Keep in mind that what we do today, what we do right now, from now until the end of class, is not going to be on your quest. So your quest is going to go up through slope. Okay, so today we're going to talk about equations of lines for the rest of class, and that's not going to be on your quest. So we're going to make extensive use of the slope-intercept form of a line, and we're also going to see the point-slope form of a line. So here's a little important note here. We're skipping sections 2.1 to 2.3 in the textbook because they cover this topic called functions that isn't part of our curriculum. Okay, we actually talk about functions in college algebra, the next course. So from this point forward, if you see the word function in your textbook, mentally replace that word with the word equation. Okay? And if you see symbols like F parentheses X, G parentheses X, or H parentheses X, mentally replace those symbols with a Y. All right. So for example, if you read, consider the function f parentheses x equals 3x minus 2, you would translate that. You'd replace the word function with the word equation. And this f parentheses x, you'd replace with a y. It's only going to happen once or twice. Yeah. Okay, so function means equation, f parentheses x means y. Okay, so moving on, slope-intercept form of a line. For linear equation of the form y equals mx plus b, right? The slope of the line is m, so that's your slope, and b is the y-intercept, 0, comma b. It's the place where the line touches the y-axis. In the lesson you were just working on, I'm pretty sure everybody got to the car problem, right? We saw a car depreciation where the car was worth originally $10,000. It depreciated at a rate of $500 per year. And we came up with this equation for the value of the car, y, after x years had passed since purchasing the car. Y equals negative 500x plus 10,000. Right, many of you wrote it as 10,000 minus 500x. Those are equivalent. Because it starts at 10,000, you subtract 500 year after year after year, so you multiply 500 by the number of years, x. So can you see that this is the form y equals mx plus b? That negative 500 is my slope, and that 10,000 was the y-intercept, b, the original price of the car. So I'm going to write an equation in slope-intercept form of the line that has a slope negative 2/5 and a y-intercept of 0, 3. So slope-intercept form is y equals mx plus b. I'm going to replace the m and the b with the information that they gave me. And I get y equals negative 2/5 x plus 3. Just replace the m with the slope that they gave me and the b with the y-intercept that they gave me. Does that make sense? So I'm just starting with the equation of a line, y equals mx plus b. Replace the m, replace the b with the given information. So it means every solution, every xy pair, like if you think about the car example, right? Y equals negative 500x plus 10,000. Every time you plug in an x and get a y, it gives you information about this car, about how much it's worth at a certain point in time. right? So if I make an XY chart here, if I put in 0 for X, negative 500 times 0 plus 10,000 is 10,000, right? So at year 0, the car was worth $10,000. Okay. What about 1 year later? If I put in a 1 for X, I have negative 500 times 1 plus 10,000, 9,500. 9,500. Right. So I could keep putting in X's and getting Y's, and this tells me the value of the car. So this is an equation that models the value of the car, right? X is representing how old the car is, Y represents the value of the car, and that equation describes every possible value of the car in time. So every line can be written with an equation like this, right? In this case, the negative 500 was the slope, M, and 10,000 is your starting point, which is your y-intercept, B. Mm-hmm. Yep. Oh no, we're still going to be talking about slope, just going a step further with it. Okay, so now I'm going to try to find the equation of a line that passes through the points negative 1, 4, and 2, negative 5. So it can be helpful to have a visual, negative 1, 4, and 2, negative 5. So 1, negative 4, about here, right? And 2, negative 5, were those the points? Oh, sorry, negative 1, 4, I mixed it up. Negative 1, 4. Negative 1, 4, left 1 up 4, and then 2, negative 5, right here. So I'm looking for the equation of this line. That's a line, every point on it has some coordinates x comma y, and I want to find the equation of this line that describes all the points. All right, so I can start by writing down y equals mx plus b. Every line, as long as it's not vertical, can be described in that format. Okay. So we have 2 points given. We're arbitrarily going to circle the first point. Okay. You can circle either one. Just circle one of your 2 points. I chose the first one. Next, I have to calculate the slope of that line. Okay. Remember, slope is y2 minus y1 over x2 minus x1. So I subtract negative 5 minus 4 over 2 minus negative 1, negative 9 over 3 is negative 3. Mm-hmm. It comes out the same, right? Comes out to negative 3. So you can do the subtraction of your points in either order, as long as you do the same order on the top and the bottom. So it should come out to negative 3 either way. Okay, my next step is to just write y equals mx plus b. Just copy that down. That is the equation of a line. That's the form that you're going to be using most often. Y equals mx plus b. What I need to know is m, and I need to know b. I've already got m. We calculated that in the previous step. So next step, replace the m with a negative 3. So I have y equals, instead of mx, I have negative 3x plus b. And then b is your y-intercept. And I sketched a picture of this line a minute ago. What does it look like the y-intercept might be based on my terrible, terrible picture? 1. It's 1 or around there, right? So we're going to do a calculation to make sure that that's right. But I think that the y-intercept is 1, which means that I think that b is 1. But to be sure, because when you draw a picture, it's not always accurate. To be sure, I'm going to rewrite this equation from the previous step, but replace the x and the y with the coordinates of the point that we circled in step A. So I circled the point -1, 4. So -1 is an x coordinate, so I'm going to replace the x with a -1. And I'm going to replace the y with the y coordinate of 4. And then you solve for b. So that's -3 times -1 is 3. Subtract 3 from both sides, and you get b equals 1. So we were right from my picture. It looks like the y-intercept was 1, and it is. So I solved for b. That's part F. Part F, b equals 1. And then part G, plug that value of b into the equation with the star, which this one was supposed to get a star, sorry. Go back to the equation where you had -3x plus b. And now we know what b is, right? So I put in a 1 for the b. And that's the equation of that line. Every xy pair that makes this equation true lies on that line. That's what that equation means. Right. Right. We're trying to describe all the points on the line, right? There's an infinite number of points on a line, right? So there are an infinite number of xy pairs that could make this equation true. And so this is an equation that describes all of the points on the line. So when you're trying to find the equation of a line, it's always going to look like y equals some number times x plus some other number. And that will be your final answer if the question directed you to find the equation of a line. Y equals some number times x plus another number. All right, we can also find an equation of a line using another method. You can always pick the method you like best. If you like the method we just did, you can just plug your ears for a minute, right? But this one has its advantages, okay? So suppose we have a non-vertical line, it has slope m, and it goes through the point x1, y1. An equation to describe this line would be y minus y1 is m times x minus x1. So we call that the point slope form of a line, because all you need is the slope and 1 point. So I'm going to do the exact same line, the line that goes through the points -1, 4, and 2, -5, but I'm going to use the point slope form this time. So step 1 is to find the slope of the line. We did that in the previous example, it's -3. Step 2 is to write down the point slope equation of the line and replace the m with the slope number. So I'm just going to copy everything exactly as it is, but replace the m with a -3. And then I'm going to rewrite the equation from the previous step, but replace x1 and y1 in the equation with the coordinates of a point on the line. Okay, if you had 2 points given to you, you just pick one. Doesn't matter which one. Okay, so which one do you want to pick? The first one? Good idea. All right, so I'm going to replace y1 with a 4. So I have y minus 4 equals -3 times x minus x1, which is a -1. Then I'm just going to simplify this. I'm going to solve this for y. So I've got y minus 4. Distribute my -3, and I get -3x minus 3. Add 4 to both sides, and I get y equals -3x plus 1, which is the same equation we got when we did it the other way. So we have 2 methods. You can use whichever one you prefer. Okay. So I know it's a lot, and you're not going to get it by watching me do it. The only way that you're going to end up being able to do this is if you do some on your own. So jump to the activities. I will be coming around to help as needed.